Hey guys, back again with me, Fidisky4Takudewan, and today we'll continue our topic of red-black trees. Today, this video will show you the concept of insertion in red-black trees. So, let's go ahead. We will need to remember the golden rules of red-black trees, the rules that make red-black tree what they are. Every node is either red or black. No nodes is considered as black. Red nodes will always have two black children. And root node is always black. Every path from node X to leaf node will have the same number of black nodes. Okay, guys, this is very important. You need to remember these properties and the golden rule, alright? Because we will always check for violations when performing insertion. So, keep in mind that you will need these. Let's go. Insertion. First, insert the node using BST insertion algorithm. The inserted node will be colored red. So if you guys, as I've said before, you guys need to understand BST insertion algorithm first. So you'll traverse down the tree and check whether the inserted node is smaller or bigger than that particular node, and go along with the flow. But remember that inserted node will have initially be colored red. Second, check for violations. The golden rules guys, remember. If violation exists, then perform rotations or recoloring, it can be both, based on several conditions. This is what I've told you before. So in red-black tree, there are two things that you can do to fix the red-black tree, which is rotation and recoloring. So those two things are essential to be understood. Let's go. Insertion concerns mostly with the uncle of the inserted node. So when you insert a node, pay attention to the uncle's color, because it will determine the steps that you will need to do next. It's better if we just directly look at the example, shall we? Case 1, where a red node has a red parent and a red uncle, full of red. Red node, red parent, and red uncle. First, we need to recolor the parent, uncle, and grandparent to their complement color. This is the simplest case. When you insert node, it will be treated as red, right? And if it's red, it has a red parent, and the uncle is also red, then recolor the parent, uncle, and grandparent to their complement color. This is the simplest case. Complement means red becomes black and black becomes red. It can't become other colors. Remember, the first rule. Check whether new violation occurs. Because we changed the color of the grandparent, it might be that the grandparent's parent, are you confused already? Hang with me. The grandparent's parent is also red when the grandparent is recolored to red. So it's possible, it's very possible. So what you do is you do another case based on the problem that you faced. So an example of case 1, let's see, you have a new red node here and it has a red parent. Oh, this is troublesome. Therefore, because the uncle here is also red, you will recolor the parent, the uncle, and the grandparent. So we have a red node here, but we will recolor. Let's see, we will recolor. I will change the color of this ink. So we have the same color, same node, no rotation at all, the simplest case, but red will stay red. Red becomes black, the parent, the uncles becomes black, and the grandparents, from black it will become red. This might be a problem if the grandparent is recolored red, but then the parents of the grandparent is red. So we need to check here, right? But so far this is good. Let's see here. One black note, no violations. Alright, let's move on. Case 2, where a red note has a red parent, but it has a black uncle and is an inner leaf. So case 2 here, we perform rotation to the direction opposite of its position, to itself and its parent circle. So what we do is, if the inner node, our new node, the inner node is at the left side, then we do the right rotation. If it's on the right side, then we do a left rotation. You understand when I give you the example. Okay, so case 2 is a case where it now leads to case 3. Let's see the example. Case 2 example. So we have a new node here, and it's an inner node. So it's case 2, right? Because it's an inner node. So what we do is, because it's at the left side of the inner node, we will do a rotation to itself and to its parent circle. This is the circle of itself and its parent circle, to the left, because it is the right node of the parent. So how will it look? Because we do a rotation here, it will look like this. So the grandparents stay the same, but then due to the rotation, the child will be the parent of the original parent. That's scary, but that's normal in the town of Red Black Tree. The child will be the parent of the original parent. See, there is rotation. Actually, it's here, it becomes here. Rotation to the left, tan goes here. And the color, it stays the same. Red, black. As you've not noticed that there's still a problem here. Yes, 2 coinciding red nodes. So this is actually our third case. So it comes to a point where we have case 3, where a red node has a red parent and a black uncle, and is an outer leaf. See, from case 2 we can transform into case 3. What we do? We perform rotation to the direction opposite of its parent's position, to its parents and its grandparents' circle. So the rotation is still the same as case 2. We do it opposite of its position, of the parent's position. The problem is the point where we do the rotation is different. Before it's the child and the parents, now it's the parents and the grandparents' circle. Now we swapped the color of the former parent and the grandparent after they're doing the rotation. So this is the recoloring part. Let's see the example. So before we have 11 here, 10 here, so we do a rotation to the left and we treat this 10 as a new node. So as the algorithm goes, we do a rotation first, right? So it's at the left side, so we do a right rotation. Is it here? Nope. We do it in the circle of the parents and the grandparents. So we do the rotation about here. So we know that the shape of the tree will be like this: 11, 10, and 18. Why? Because we do a rotation, remember? So this one will become the root, but the root will become the right child of the new root. Do rotation, remember? So we did a rotation. Now we should recolor the color of the parents and the grandparents. So it stays the same. Red, originally red becomes black, and originally black becomes red. Voila! Done! Any violations? No coinciding red nodes. The root is black. The number of roots? 0, 0. Same. So yeah, that's about it. That's all about insertion. You've become an expert in insertion, and here, just quick reference for you guys. This is a particularly good website because it allows the visualization of the red black tree and play around with it, get familiar to the algorithm, and I will put the reference and the description below. So maybe I'll make a video for deletion, but I'll see. So thank you guys for watching and see you in the next video. Peace out.